For question number 1, to solve it, we have to use the triangle angle bisector theorem, which says that when you're given a triangle and through that triangle is a angle bisector, it splits our triangle into proportional segments. So what that would look like is segment BC over segment CD will be proportional to segment BA over segment DA. And it is set up this way because it's following the same pattern where we started with BC, which is in the first triangle. So we start with BA because that's in the first triangle. CD is from the second triangle, and that's on the bottom of my fraction. So DA, which is also on the second triangle, also has to be on the bottom of the fraction. So because of that theorem, we can solve for our side t, which is missing, by setting up a proportion following the proportion we just wrote with those side lengths. So instead of BC, I have 13. Instead of CD, I have 15. In place of BA is the letter T. We don't know what that side is. And then we have 41 for DA. We're going to cross multiply. 15 times T is 15T. 13 times 41 is 533. We'll divide out 15 from both sides. And that gives me that T, or my side BA, is equal to about 35.53. On question number 2, it works in a fairly similar way. Our proportion is just set up a little bit different. And this one is using the triangle proportionality theorem. And that tells us that if we have this one triangle and we draw a line through that triangle such that it is parallel with a side on our triangle, so like here we have TS is parallel to RP, then that puts our triangle in proportional segments so that we would have QT over TR equal to QS over SP. So it's splitting our segments into a fraction on one side of the split from our line that was added over the other side of our original segment. And that's happening on the other side. And it again follows suit where if you are on the big portion here on top, so QT I put on top, then QS also has to be on top of the fraction. We can replace those letters with the numbers that we know those side lengths are represented by. So we have, instead of QT, we have 12. Instead of TR, we have 5. Instead of QS, we have 16. And instead of SP, we have Z, because we don't know the length of that side yet. We're going to cross multiply again. 16 times 5 is 80. 12 times Z is 12Z. We'll divide out 12 from both sides, and that leaves us with Z, which is about equal to 6.67, which is really 6 2/3.